Okay, today we are going to see how a partitioning is going to create, or how we can create the partitions, and how we can use a LVM. Okay, what is mean by LVM? Okay, so all the stuff here. Okay, let's say what in the Windows we do. Okay, in the Windows what we will create here, it is that we can create a C drive, D drive, E drive, something like this, right? C drive, D drive, all the stuff. So this is one partition, second partition, something like that. So up to A, B, C to Z, up to you can create this many partitions, right? But how the partition can be done here? Okay, basically what we will do here, it is we have on a hard disk. Okay, so in this we will do a partitions like this, right? So first maybe C, second one D, E, F, something like this. Okay, so before that, so before creating the partitions, so okay, so what are the methods should follow? So how many partitions maximum we can create? Okay, what type of partitions we can create maximum? Okay, what type of partitions we have to create? Okay, so if you take a hard disk, okay, so this hard disk partitions can be done in two ways. Okay, one is that, okay, this one is primary 1, primary 2, primary 3, and primary 4. That's it. Okay, another method is that we can create a partitions, okay, like this: primary 1, primary 2, primary 3, and there is one more is called a logical one. Okay, this one is extended partition. In that we can going to create a logical partitions. Okay, L1, L2, L3, L4. So the method is follows for both Linux and Windows, or any operating system follows the same method. Okay, so type of primary partitions if you want to create, then the maximum for the one HDD you can create four primary partitions. Okay, this is maximum for any operating system you can take. Okay, or Windows or Linux. So okay, you can create primary 1, primary 2, primary 3, primary 4. That's it. No more partitions. If you left the space after the creating this P4, there is some space, you cannot utilize the space, that should be wasted. Okay, so or else we can create a three primary partitions. Okay, 1, 2, 3, and after that you can create a extended partition. In that you can create how many logical partitions you want. Okay, like this you can create it. But as I'm saying here, it is that we have to create like this. But are you sure that Windows is also following the same? Okay, so for that we can just going to see here, it is that a Windows disk management here. Okay, see here, this is my hard disk. I have disk 0 and disk 1. Okay, in this disk 1 I have only single partition, and disk 0 I have 1 2 3 4 partitions I have. Okay, so if you can see the representation how this the partitions is called in Windows. Okay, you can see here the representation says black one is unallocated. Okay, and the blue one, this blue one is a primary partition, this blue one is a primary partitions. Okay, so you can see here this blue one. Okay, these partitions are logical, but you can also see there are a green one, this green line, right? Okay, that is called as an extended partition. So as I told you, same way, okay, one primary partition, secondary primary partition, third extended partition, and logical one and logical two. Okay, this one, yeah, here there is only one partition, there is no other partitions. Right, so like this in Linux also we create the same type of partitions. Okay, so what we can do here it is, we can create either 4 primary partitions, okay, or 3 primary partitions and 3 primary plus 1 extended plus how many logical you want to create, a logical partitions you can create. But I didn't get you. Extended and logical volume. So extended can be created for extending the partitions. Yeah, see, as I said you, one hard disk you can only create 4 primaries, right? So but you created only 3 primaries. After that you want to create any partition, so which partition should support here? So you cannot directly create a logical partition there, because the space is going to be either you can create a primary or either you can going to create an extended partition. So extended partition in the sense this partition is support a one layer kind of stuff, like this is only the layer of partition extended layer. So in this extended layer we can create the logical, but what this extended do here it is that the it will give you a what I can say that it will give you a provision to create n number of logical partitions. Okay, that's what extended partition do in this case. Okay, logical partitions, what does mean by, in the sense which are created under the extended partition or the extended layer, that is called as a logical partitions. But what the difference between this primary, extended and logical? Okay, the primary it's called as a directly created on the disk itself, but extended there is a multiple layers. So suppose say you have one layer here extended, this is called as an extended layer. After that you are going to create a logical partitions. This one is extended partition and this is in a logical partition. So if your extend is not available, extend is going to be offline, or sometimes something happened to your extended, then all the logic will go disappears. But most of the cases this is not going to happen, so just I am saying for example for you. Okay, so extended layer can be created. Under that extended layer you can be able to create a number of logical partitions. But if you have a VM environment or the virtualized environment, at maximum you can create 15 partitions as a logical partitions. As a logical you can create maximum 15 partitions. Okay, so how the disk um, conversations or the how the disks follows in the Linux. Okay, so most of the HDA, okay, these numbers, this A, B, C, D, okay, this one will change up to Z. Okay, this is for a IDE connections, IDE disk. Okay, for SATA disk, what it will create here, it is that SDA, SDB, SDC, something like this up to Z partitions for SATA. Okay, so for virtual, okay, this for SATA or SAS also will be same, or SCSI also will be same, partitions will be like this. Okay, for virtual, okay, virtual, how it will be going to be here, it is that VDA or VDB, okay, up to Z. This is for virtualized disks. Virtualized disk in the sense, this is only applicable in the RHCL virtualization. RHCL virtualization in the sense KVM. Okay, for if you create a virtual machine on the VMware and you assign a disk, this will not create like VDB, VDA, something like that. This will create only like SDA, SDB, something like that. Okay, so like this IDE partitions will be start from SDA, SDB, SDC, something like that, and SATA partitions will start from SDA, SDA. In the sense, if you attach one disk, the one disk will be called as SDA. If you attach one disk in the SATA, it is called as an SDA. If you attach one more disk, that naming convention will change as SDB. Okay, and if you attach one more disk, yeah, you're not able to catch. Okay, so where you stuck? That is only the naming convention. That's it. Okay, in the sense, IDE in the sense, IDE in the sense hard disk connectivity, right? If you see an IDE hard disks, IDE in the sense hard disk connectivity. I'm saying SATA. Maybe you may not aware of the hardware. Okay, let me show you here. Okay, IDE disk. Okay, so IDE disk will be like this. See, okay, the cable will be for like this. You can see the connectivity for the IDE hard disks. Maybe you are aware of. Okay, so this type of connectivity IDE hard disks. Okay, if you connect this type of, if you install this type of hard disk in a Linux environment, so for first hard disk, if you install or if you attach a first hard disk to your Linux machine, then the naming convention for that device is SDA. If you attach one more disk, that naming convention of that device will be SDB. Okay, SDA, SDB. So how many disks you want to attach, that many disks is going to be changed, like A, B, C, D, E, F, G, like that. Okay, for SATA connectivity, if you see maybe you are aware already, I think so. Okay, SATA connectivity like this. See, this type of SATA connectivity, this type of SATA connectivity cables. Okay, this type of hard disk, if you attach to your Linux, okay, then you are going to maybe SCSI or SAS or whatever it is. Okay, maybe you can see that SCSI disks. Okay, this type of SCSI, maybe you can see here this type of, but nowadays we are not using this type of cables. Okay, in a previously I was used. Okay, SAS, or if you want to see a SAS, okay, SAS will be SAS disk. Okay, SAS disk will be like this. So it's almost like SATA only, but the connectivity for SAS will be different, little bit different. Okay, I can maybe show you SAS cable, something like this. See, like this is called as a SAS, or else you can also say this type of cables. Okay, so that type of cables, if you attach that type of disks connectivity, if you attach to your Linux, then you are going to get the naming convention as SDA. Okay, the naming convention is SDA, HDA. Okay, VDA or VDB, VDA or VDB. Okay, so this is for virtual. VDA in the sense virtual, SDA in the sense SAS or SATA. Okay, or SCSI. Okay, this is for ID'd hard disks. You understand? Okay, so that is the naming convention. Why I am saying here is that if you are going to create a partitions on the disk, as I showed you as of now, disk partition on the disk management on the Windows. Okay, how did you see that? Okay, there is a disk 0, disk 1, something like that you see, right, in Windows. Okay, in the same way in Linux there is no disk 0 or disk 1. Okay, the naming convention is called as like this: HDA, SDA, VDB, VDA, something like this. Okay, that is only I am saying to you. Okay, in Windows it is called disk 0, disk 1, disk 2, something like that. In Linux it is called SDA, SDA, VDB. Okay, like this. Okay, so as of now we see that okay, we can create only maximum is primary is 4 and primary 3 are extended 1 and logical 15 we can create. Okay, so what is the file systems we can utilize? Okay, so as of now if you see a Windows, you can say NTFS file system or FAT file system or FAT32 file system, something like this. Okay, we have something like these file systems, but in Linux we have ext2, okay, ext3, ext4, okay, and xfs. Okay, like this we have the convention. So here also we have a vfat for pen drives. Okay, so this is the types of file systems we have on the Linux. So ext2, ext3, ext4, xfs. So what does mean by ext2, ext3, ext4 here is that, so most of the file system works on the same, like whatever the file system you format, whatever the disk you created and format with the file system, but there is only the limitations we have on the file system is that if you create a ext2 partition, okay, maximum 16 GB of file you can file in size you can place in a ext2 file system. Okay, but ext3 we have in ext2 we did not have a journaling checking in the sense whenever you put any files on the Linux or the any file on the partition, what by default it will check for your checksum in the sense what the file is written properly or not. Okay, is it placed in a proper freed blocks or not? Okay, is the file is good in condition? All the stuff it will be verified automatically. That is mean by the journaling. Okay, so here there is no journaling support in ext2, but ext3 we have journaling support. Okay, not by default, but you have to enable manually. But in ext4, okay, journaling we have automatically in the sense whenever you place any files, it will by default verify all the files for its extensions, all the stuff. Okay, ext4 you can by default, okay, it will support a 1 EB partition size. Okay, in EB means petabyte exabytes. Okay, 1024 into petabytes equal to exabytes. Okay, this much size of ext4 can be supported, but practically it's not. We can say something like that, but it practically does not support that much. So the maximum is at 100 TB you can create. Okay, so in ext4 the maximum is that 16 TB you can create. Okay, in XFS you can create maximum is that 500 TB. Okay, so this is the file systems we have. So it's difference we have in a different manner, that okay, the ext4 block size will be different and ext2 block size will be different, and ext4 block size will be different. Okay, XFS block size will be different. By default ACL is enabled on the XFS. Okay, manually you have to enable ACL on the ext3 or ext4. Okay, like that. So there are the differences are there. You can just maybe refer some documentation for how, what is the minor and major differences between the both the file systems. Okay, so now let's step into our practical session and see that how we can going to create a partition. Okay, let's say what I'm going to do here, it is that whether I have any external partition to this one or not. Let's see. Okay, I did not have any partition here. What I'm going to do here, it is that I'm going to add a one partition. Okay, hard disk and SCSI hard disk here. Okay, you can also create IDE, but it is not supported yet. SCSI partition I'm going to create here, start and create new disk. Okay, so I'm going to create maybe a 30 GB of disk space. Okay, and I'm going to place this one. Okay, that's it in the VMs. Finish. Okay, I have created my 30 GB disk space. One more disk I have created. Okay, now what I have to do here, it is that simply reboot my server. And after rebooting we can access that server. Okay, now what is the command you have to use here, it is that fdisk -l. Okay, now you can see here SDB, okay, with 32 GB of space, and SDA is 40 GB of space, right? So that's what I said, this is my first hard disk and this is my second hard disk only, right? Hard disk. right? We attached a extra disk, right? Okay, now what I'm going to do here it is, we are going to use this SDB for creating some partitions on this. Okay, so now fdisk is the utility. Okay, now provide which disk you wanted to do a partition. Okay, sdb not sdba, sdb. Okay, so now here you can type m, so it will provide you the help. Okay, this is all the options, but in this all the options we are going to see only something like um, t option, okay, and n option, and w and x option, sorry, w option. Most of the times we see p option. Okay, rest of the options we may not see. D also we can see. Okay, but rest of the options we may not see. Okay, but most of the times we may not use those part options as well also. Okay, and for creating new, you just to type n. Okay, now it is asking, see here, what is you want to create now? You want to create with the primary, or you want to gather with this extended? Okay, first one should be a primary always. Okay, and hit enter. So now it is asking you for the partition number. Okay, which partition number you want to utilize? 1 to 4. See here, it is giving only 1 to 4. Why? Because the primary can only be created from 1 to 4 only, right? So that's why it is giving 1 to 4 only. So by default I want to create 1. Okay, now it is asking you for the which sector numbers, from which sector to which sector you wanted to create your partition. Okay, either you can provide your sector numbers as well, but as of now I am not calculating my disk space in sectors. I want to calculate in the space in the MBs and GBs. Okay, it enter, no, not provide any sectors here. You don't, if you're not aware anything of about the sectors. Now provide a size plus. Okay, how much you want to create? I want to create a 2 GB partition. Okay, plus 2G, in the sense I am creating 2 GB a partition size. Enter. Okay, now let's see whether partition is created or not. By hitting the P will print your partition table. Okay, now my SDB1 has been created. From starting sector is 2048 and end one is 4196, something like that. Okay, how many blocks are used and what is the ID here? So ID is 83. If you can type L, okay, it will show you all the IDs here. So what does mean by 83? So where is my 83 partition number? Here 83 is Linux partition. Okay, 8E is Linux LVM partition. Okay, the fifth number is extended partition. Okay, so what type of partitions we can create? So there are a number of, but out of it we use only few. Okay, so maybe extended, or this number, why I am again repeating, so this also we can create swap partition. Okay, Linux partition and 80. Why I am showing these numbers here, it is that you have to remember that IDs always. Okay, so 82 is for Linux swap, 83 is for Linux, and 8E for Linux LVM. Okay, that you have to remember. Always extended partition is 5. So there are a number, but most of the times we may not use. Now what I have to do here, it is, as of now I have created the partition, but I did not update the partition table yet. So to do your partition table update, what you have to do, WQ, write and quit from the session. Okay, now what it's saying, the partition table has been written, altered, but if you create a partition, the kernel does not know that whether the partition is exists or not. So to do update your kernel, what you have to do, type here, it is that part probe /dv /sdb. So what we are doing here, it is that we are updating our kernel, saying that yeah, I have created the partition. Remember this, okay? Whenever I reboot the machine, do remember to load this partition related information. Okay, that's what I am saying to kernel now. So I have updated to kernel. Now go to fdisk-l. See here, my partition has been created. Okay, now what we have to do, this one, sdb1, sda is above 1, right? Okay, so sdb1 has been created. Now what I have to do here, it is that you have to make the file system. So as I said, ext2, ext3, ext4 or xfs, any file system you can make it. So mkfs, in the sense, make file system dot, which one you wanted to make, ext2, ext3, ext4, anything you can provide. Okay, /dev /sdb1. So when I say make the file system, then what it's going to do, enter, then what it does, so it is going to create a blocks, different types of blocks. Okay, it's going to create a super blocks, it's going to create a data blocks. Okay, and it's also define that partition into a different unknown numbers. Okay, why it's going to create a different type of unknown numbers or the super blocks or the data blocks? Because whatever the file system, whatever the files you are going to store on that partition will be calculated as numbers. Okay, the file system, it does not understand by the operating system. Then the operating system only understand zeros and ones, right? In the same way, so the unknown numbers will be calculated like this. See here, so how many blocks has been created, here it is, this how many unknowns has been created. Okay, this many blocks is formatted and this many unknowns has been created. So whenever you keep some file on that, it will be updated the partition tables in the super blocks, says your file 1 has been written from this unknown number to this unknown number. Okay, and you have updated file from this unknown number to this unknown number. So it will calculate all the files like this only in the Linux. So whenever you are opening the files, what it's going to do here, it is that the hard disk is going to look into that actual what are the unknown numbers has been written, from where to where the file has been written. So that is going to read that portion of hard disk, then your file will be opened on the, whenever you clicking on the file, it's going to read that inode range. What is the inode range? It is written on that piece of information, it's going to read on the hard drive. Okay, so now what I did, I make the file system, but I did not mounted any partition here. So for to do thing, what I have to do here, it is create some mount point or some directory. For that directory we are going to use it as a mount point. Okay, so what I'm going to do here, it is that part 1 I am saying mkdir part 1. Now mount /dv /sdb1 to part 1 and say mount -a for any errors and it is not properly mounted or it's going to refresh. Okay, now type df-h. Yes, how much space we have created here? So with 2 GB size we have created Out of it 6 MB is already used by the file system and 1.8 GB has been free here. Okay, so now if I type df-i, it is going to show my inode numbers. So how many inode numbers it has and how many free inodes it has, how many inode numbers it is used already. Okay, how much percent of inodes has been used. Okay, this is the inode number information. Something like this, if I have some files here, if I copy from here to there, okay, anaconda file or initiate file, ravi file, and this file I'm going to copy into part 1. Okay, remember this here, it is that how many inodes I have and how many inodes I used. Okay, now copied, and I'm going to show you now how many inodes has been used now. 15. But if I type df-h, still it shows 1% only and 1.8 GB is free, right? So if your file size is smaller, then you cannot identify in the space, so this space can be calculated only some 1 MB file is copied or 2 MB file is copied, then that time you are going to see this percentage in a human readable format. But the inodes, each and every file will be calculated in the backend as a inodes. Okay, so the inode numbers, from way to way the inode number has been copied, all the stuff will be specified here or shown in the df-i option. So now what I did, I have created the partition, standard partition, and I have formatted the file system. I have made the file system on that partition and mounted that partition to the one directory. So why we are going to see this? So here the example is simple. Okay, if you have a home, okay, I can take maybe different. Okay, if I have a home, then how you will enter into the home? Okay, you can enter by door, or if you are crazy, if you can enter from the window as well, right? Or if you can enter from the back window as well, if you have. But if you enter from here, or if you enter from here, or if you enter from here, where you are going? Okay, you are going into the inside to the home. Okay, in the same way, if you mount your partition to the any of the directory, okay, you may be mount to the, as of now I said example like part 1, or if you may be going to mount into the different learn one something, if you say, okay, or slash, maybe you can say something like u01 u02, something like that. Okay, anything you can specify here. Okay, but if you see from here, or if you see from here, or if you see from here, what you are seeing, whatever the files are there inside the partition, okay, you are seeing the file system. So as an example, as simulation of this, simple. Okay, if you go from any window, but you are going inside the home. So if you see from this directory, or so if you utilize this part 1 as a mount point, or learn 1 as a mount point, or u01 as a mount point, okay, but ultimately you are going to see the files what are there on the partition, okay, not on the this directory. Okay, you are getting my point? Okay, so simple, right? df-h. So this partition information, I am mounting it here, and I am looking from /part1. Okay, if I want to unmount /part1, okay, maybe I can make some directory as /u01, and I'm just unmounting this part1 here, okay, and mounting /dv/sdb1 to /u01, Okay, but if I go to slash u01 and see the files, what are there? So what are the files are there on this partition only, right? If I see ls-l slash part1, nothing is available because I unmounted that file system. In the sense, I removed that window. There is no window now. If you go to that window, you will go nowhere, right? So if the window is attached to your home, then if you go from that window, then you will go to home. But if you remove that window, kept aside, and if you are going into that window, you will go nowhere. Okay, in the same example, so if the directory is mounted to some partition, and if you are entering to that directory, which means that indirectly you are looking at the files of that partition. Okay, you get it? That's what I told you, right? Nothing is there, right? Yeah, after unmounting it, it will be empty only, right? I have created empty directory, but I mounted that. Yeah, okay. So now you got the what is mount point or not? So what is the doubt in here? See, what I'm doing here, it is I'm just mounting. I have created this partition and created the file system. Okay, so what I did here, it is I made my home. Okay, and I made my home's walls. Okay, 4 walls I made, but I did not made any door. Then how you will enter into that room? Not possible, right? So ultimately you have to make some window or you have to make some door. So what I'm doing here, it is that by mounting to another partitioning, another folder, I'm opening the door to that partition. Okay, in the sense, now my door is u01. If I enter into that door, then I can able to see the files on this partition. Okay, that is simply say mount point. So mount point is used to see the files inside the partition. Okay, simple. So suppose say if you want to make a door on the east side, you can make east side. If you want to make the door on the west side, you can make the west side. If you want to use a north side, you can use north side. So any side you can use it, or any directory you can use it for mount point. Okay, which should be free. So like that you can mount any free home directory. So under the directory you can also mount like something like that. So as an example I am saying here u01 I have mounted as of now. Okay, but what I am doing here, it is that mkdir-p under u01 I am going to make one more directory called lan1 say. Okay, now what I am doing here, it is that going to mount slash dv slash sdb1 to u01 slash lan1. Okay, now if I go to u01, there is nothing, right? There is lan1, but if I go to lan1, then there is actual files. So which means that if you are looking at lan1, sorry, if you are looking at u01, the u0 is not mounted to any file system. Okay, it is representing your slash, still it is under slash only, but your LUN1 is mounted to the partition like this. Okay, now what we did here, it is we have created partition, we make the file system, we created the mount point and mounted it. Now if you reboot your machine, then your file system is not going to available. Then if you type df-h, it's go off, then sdb1 is will be not visible. To mount your file system permanently, then what you have to do here, it is that edit the configuration file called fstab. Okay, vi fstab file you have to edit this one and make the entry in the last. You have to add the entry here. So first column you have to add your partition name. What is the partition name you have made and what type of file system you have created, ext4 and ext4, and which mount point you want to mount. Okay, I'm going to mount it to /u01. Okay, and defaults. Okay, defaults you write it as defaults only. Okay, 0/0 space 0. Okay, I will tell you later what is this defaults and zeros and 0. Okay, don't worry about that. But as of now, what you have to do, you have to provide your device path, file system type, mount point, defaults, 0/0 space 0 defaults. Okay, and save your file fstab. So what I'm doing here is that I'm just unmounting this one as of now. Okay, I'm not going to mount any partition, but if I type mount -a, the partition is automatically going to mount. Oh, okay, we made some mistake on the fstab file. Okay, sorry. So it's other way. Okay, first one is mount point and second one is partition type. Okay, this one file system type, and now you have to type mount -a. So if you type df-h, your partition is going to mount automatically. If you reboot your machine also, your partition will be come back automatically. So if you add a entry on fstab, which means that you are mounting your file system permanently on the Linux machine. Okay, so this is the entry we made on the fstab. So if you do this standard partitions, okay, it will be good. But the thing here it is that if you want to expand your partition size, okay, then it's going to be tough time for you. You cannot immediately extend your partition, or you cannot immediately going to decrease your partition by using a standard partitions. Okay, standard partitions cannot be directly increased or decrease your file system size on the go. Okay, if you want to do that, then you have to use a method called LVM. Okay, logical volume manager. So how we are going to define a logical volumes, okay, how we are going to extend, how we are going to decrease the file system size, okay, that's we are going to see on tomorrow's class. Yeah, continuation.